Hello there guys, welcome back to our fifth LibGDX tutorial for building our spaceship scrolling game. So in the previous video we managed to address different screen resolution for the game. However, the issue was that for different Android devices the code worked, but for some reason for desktop application it didn't work. The scaling wasn't working correctly, which makes me think that there is a problem maybe with the desktop engine. So what am I gonna do is try to solve this issue first, because most of our tests need to be done on the desktop. The emulator will always be slow, so it will cause lots of problems if we always depending on the emulator. So we don't want to see something like this, if you know what I mean. Okay, so this is first, and yeah, so we will address this very quickly. Now, in order to address this thing, okay, so let me see. Now this one, it appears accurately, suppose. After that, after we finish the desktop issue, we'll address the problem of the input on the display. Okay, if that makes sense to you guys. Okay, so first what we need to do, what do we have here? We have come on dude. Okay, so we have these two guys, the virtual width and height, and we are having a problem with the scale. So what am I gonna do is go to the specific project of the desktop launcher, and I will do some trick here. Before that, I will just create a flag. So public static boolean desktop is running, desktop app running equals false. Now this flag will help me determine that if this game is running on desktop or on Android. So I will go to the desktop launcher. Okay, so the game is gonna start from here. So what am I going to do? Just add this very simple line of code. So g01 game dot desktop app running equals true. So when I run the game on desktop, this project starts, so it will set the flag to true. For other projects this flag will not be set, so I have no problem there. Now let's go back here. So where's the part of initialization that I usually do? Let's do this. Just add if desktop app running, and at that very moment I will just what was the trick I did yesterday that make it work? I think I reversed these, I can't remember, I'm not sure, so let me just try it very quickly. Okay, so I just reversed these for some reason. Okay, let's hope it works. So let me run this on desktop. Okay, so the resolution is very, this is not what I wanted. So now it's being scaled a lot. Okay, so the scale X, let me see, I'll make this a scale of 1. Yeah, it will have the same scale without any percentages or whatever. Let's see. Okay, this is very weird. If I could control the width and height of the window itself, I wonder if I could do something like that. Desktop launcher. Okay, I have a better thing here. So So let's go here and search for LibGDX. It's gonna be LibGDX desktop set window size. There you go. Different window size. There you go. So okay, we create this one, we change these things here. Okay, so there are these variables here that we could change. LWJGL application configuration, so we could use this. Okay, so let's go to the Windows. Okay, so this is the configuration, right? So now I just need to set the configuration. So config dot width equals G01 game dot virtual width. Okay, so I will use the width of the and config dot height equals G01 game dot virtual height and semicolon, and I suppose that's it. So let me see. Give me a second, please. Okay, so now it looks, yeah. So now it looks exactly like the Android part. Okay, it's the same, just a little bit squashed here, but all in all, it looks great, I suppose. Now, what that means also to me, since we are setting the width and height of the window to be the same as the virtual ones, so I don't need this flag anymore, so I'll remove it here. Let's go to desktop launcher and remove it from here. Not only that, the check here, we will cancel it. Now the percentage will be 1 by 1, so it should have no effect whatsoever. So let's see here. Okay, so now it's working. Now let's run this on Android. Give it an OK here. Okay, so it's working. Now, the very last thing that we solved the desktop issue. Actually, it's a workaround, not a problem solving here, but whatever. Now, the very last thing that we need to address right now is the the click location. Since this device have different resolution, so the area of the mouse click is not the same as the the virtual one. So we need to make a mapping from the actual clicks here for the resolution 1024 by 768 into the device itself, which is, I think this one's 1080 or something like that. Okay, so I'll have to address this. So let's go to input management, and now for the checking of these. Okay, so let me see the rendering here. We've got these guys. Okay, so now let's see, where's the input? Okay, so we've got these. Yeah, mouse left, mouse right. Okay, so I will make a copy. Let me see, just make it okay. So we'll work on these guys here, right? So after we initialize these guys, we will update the coordinates of each button to reflect the actual physical display. So how do we do that? Now the left mouse x1, okay, will be equal to left mouse x1, oops, x1. We divide this by g01 game dot virtual width, okay, and then we multiply this by g01 game dot physical width. This is very important, okay. Now what that does, it will make the location of the button you know, a percentage between 0 and 1, and you multiply by the what did I do? Oh, not virtual, sorry, this is physical width, I'm very sorry, and you multiply by the physical width to get the actual width. Now one important thing is that these numbers are all integers, so you need to change this to float. There you go. This is going to be an integer at the very end, but while you are doing this, you need to make sure that these numbers are being treated as float. Okay. Yeah. This is very important. Otherwise, you will get a 0. Control C, V, 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 V. Okay. So we have the x2 here. This is gonna be x2. Now this is gonna be y1. This is gonna be y2, right? So this is y1. This is y2, right? So instead of width, we have height, and this is gonna be height as well. Nice. And this is gonna be physical height with another physical, oops, height. There you go. So before we continue, let's test this on the desktop application, and also or maybe let's just do it for both. I think it will work for both right away. Usually this is straightforward math, so we have no problem with it. Right, so there's gonna be right, the right button, another right button, right, so we have right, 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 another right, come on dude, another right, another right. Okay, so we have these guys. Now let me check this very quickly. Do we have something here? We are checking the coordinates when we are rendering things. Okay, so now, oh, I see, we need just to set the left mouse button. Yeah, we need to set these original button locations, right? So maybe I'll just make these as yeah, I need to set other 4 variables. Okay, so I need to set because they are the ones that I use to place the button on the virtual display, and right now I am treating this for checking. I'm using these for checking the actual touch locations, so I need to add 2 variables for everyone. So I'm gonna say public int v left mouse x1 and public int v left mouse y1. Okay, and I have the same here, public int the right mouse x1 and public int the right mouse y1 semicolon. So we have these. Now all I have to do before updating anything, so p left mouse x1 equal left mouse x1, before I change anything, b left mouse y1, left mouse y1, Okay, and v right mouse x1 equal right mouse x1, and v right mouse y1 equal right mouse y1. Okay, so the idea here is very simple. We are setting these locations at the very beginning to be, you know, the virtual locations of the buttons. However, as soon as we do that, we are using these to map to the actual physical display. So if we render anything right now, we will, you know, have our buttons being out of place during rendering. But we have these two buttons, four variables to help us remember where to put them. So this is gonna be v mouse x, and this is v mouse y. Yep, this is what I need. Same thing goes here, v mouse right, and oh, there's another one. Where is it? Yeah, v mouse y1. Okay, there you go. Oh, I said something wrong here, right? Yeah, I said this one the wrong way. That's this one. V, it's V, right mouse Y, 1. There you go. Okay, very straightforward. I suppose this is it. So first let us run this as a desktop application, make sure it works. Okay, there is a closing bracket expected. Okay, sorry about that. Just close this. Okay, let's run this again. Oh, another bracket. Didn't see that. Okay. And now we run. Okay. Obviously it doesn't work. The rendering seems to be fine, but it does not work at all. Okay, so let's see for this one what is going on here. So let me close this one, close this one again. Now let us debug the application. Okay, so we have, you know, this is 10. We are dividing by the virtual width right here and multiplying by the physical width. Okay, oh, sorry, just a second please. Very sorry about that. Okay, so what appears to be happening is that the virtual the physical width is not being set in the game. So all I have to do, let me stop this. Let's go here. Now where's the order of initialization? The initialize will be moved, or actually we could move the user output part initialization into here. Okay, so this way I set the physical width and height before calling the user output management. Okay, and this should solve the issue. So let's run this again. Yeah, now it is working. Good. So let's see here. It's working. Okay, again. Okay, that's wonderful. So let us go to the Android part. Okay, Android counterpart, and give it an OK. Let's see how it will work on the touch interface. Okay, so let's see. Clicking here and it's working. Okay, we're out of range. Okay, so let's check the the vertical one. Yes, it's working. Let's go to the left one. Okay, that's wonderful. You can see now we solved the touch problem. How awesome is that? Okay, so everything now is working just fine and according to our plan. Okay, so yeah, so now we solved the mapping of the virtual buttons into the physical one. So now we can focus more on the game itself, right? So let me probably I will stop the running the Android emulator, because now we finished working with this and we will focus our work on the desktop right now, since we are not going to making our tests on the Android device until later on, and usually we'll do the test on an actual Android phone. Okay, so the rest of this project we will finish using the desktop configuration right here. Okay, so what things we are supposed to start doing probably for the next tutorial is start setting the background, rendering the stars, and also preparing a better sprite for the spaceship and its shooting. Okay, so I suppose this will be all for today. Thank you for watching and have a nice day. Bye bye.